हेलो स्टूडेंट्स, आज के लेक्चर में हम लोग जो स्टेरियो केमिस्ट्री का पेपर है एमएससी पार्ट टू सेम 3 के लिए, तो इसका क्रेडिट 3 यूनिट नंबर 1 देखने वाले स्टेरियो सिलेक्टिव सिंथेसिस. ओके, so here after successful completion of this unit you were able to know the stereoselective and the stereospecific reaction. Stereoselective और stereospecific reaction क्या होता है ये हमें पता चलने वाला है. To know the distereoselective in a acyclic system, then to predict the distereoselection in a cyclic system. Okay, so see, in the introduction part we have to see stereochemistry is the study of the statics and the dynamic aspect of the three-dimensional shapes of the molecule. Okay, so what is meaning of this stereochemistry? So here in the first sentence they are explained, it has a long provided a foundation for understanding the structure and reactivity. Okay, तो ये क्या हेल्प कर रहा है हमें स्ट्रक्चर समझने के लिए और रिएक्टिविटी समझने के लिए. ये जो स्टेरियोकेमिस्ट्री है वो हमें क्या करता है, हेल्प करता है. Yes, at the same time, stereochemistry constitutes an intrinsically interesting research field in its own rights. Many chemists find this area to study fascinating due to the aesthetic beauty associated with the chemical structure and the integrating ability to combine the field of geometry, topology and the chemistry in the study of a three-dimensional shapes. Okay, so ये देखो, it is a combined study. Yes, that is here the geometry of that particular molecule, the topology of that particular molecule and the chemistry of that particular molecule. Okay, in addition there are the extremely important practical ramification of a stereochemistry. Nature is inherently chiral because of the building block of life, that is the alpha amino acid, nucleotides and the sugars are chiral and appear in the nature in the enantiomerically pure form. Okay, तो enantiomerically हम लोग देखा जाए तो ये जो है that is the amino acid, nucleotides and the sugar are available in a pure form. Okay, hence any substance created by the humankind to interact with and modify nature are interacting with the chiral environment. Okay, क्या करेगा वो chiral environment के साथ interact करेगा. दिस इज एन इम्पोर्टेंट इशू ऑफ अ बायो ऑर्गेनिक केमिस्ट. क्या है ये देखो, बायो ऑर्गेनिक केमिस्ट के लिए ये क्या है, इम्पोर्टेंट इशू है. यस, एंड अ प्रैक्टिकल इशू फॉर अ फार्मास्यूटिकल केमिस्ट. ओके, फार्मास्यूटिकल केमिस्ट जो रहेगा तो इसके लिए प्रैक्टिकल इशू है. ओके, यस, सो द फूड एंड द ड्रग्स एडमिनिस्ट्रेशन, दैट इज द FDA, the Food and Drugs Administration, that is the FDA, now require that drugs be produced in a enantiomerically pure form or that a rigorously test be performed to ensure that both enantiomers are the same. Okay, जो भी enantiomers हमें मिल रहे हैं तो जो भी enantiomers मिलने वाले सेफ है, दोनों के दोनों सेफ है, तो ये हमें FDA क्या कर रहा है, कंफर्म कर रहा है. Yes, in addition, stereochemistry is a highly relevant to the unnatural system. As we will describe herein, the properties of a synthetic polymers are extremely dependent upon the stereochemistry of the repeating unit. Okay, किसके ऊपर dependent? So it is a depend on the stereochemistry of the repeating unit. Okay, finally the study of a stereochemistry can be used to probe reaction mechanism. Okay, तो reaction mechanism क्या है, इसे समझने के लिए क्या करेंगे ये लोग, स्टेरियोकेमिस्ट्री का यूज़ करेंगे. ओके, सो बेसिकली देखो ये जो चैप्टर का नाम है स्टेरियोसेलेक्टिव सिंथेसिस, तो यहाँ पे स्टेरियो स्पेसिफिक क्या होता है और स्टेरियो सिलेक्टिव क्या होता है तो ये समझ लेंगे. ओके, सो नेक्स्ट पार्ट इज द स्टेरियो स्पेसिफिक एंड द स्टेरियो सिलेक्टिव रिएक्शन. ओके, तो सी द टर्म स्टेरियो स्पेसिफिक एंड द स्टेरियो सिलेक्टिव डिस्क्राइब द स्टेरियोकेमिकल आउटकम ऑफ द सॉर्ट वी हैव बीन डिस्कसिंग. इवन दिस फॉर्म थ्रू are sometimes used in a confusing way. Yes, figure 311, see here. Yes, this is the figure. Okay, see here the diagram A and diagram B. Okay, so see here meta chloro परबेंजोइक एसिड यहाँ पे हम लोग यूज़ कर रहे हैं. then we get this the product. Okay, see here the same product here we are using the cis. Okay, cis compound है यहाँ पे. Okay, और यहाँ पे trans compound है. Okay, if you are using this trans compound, then the formation of this compound like this. Okay, see both one as the upper side and another is the back side. Okay. Sorry. But when we are talking about the cis form, then the both the form or both the attachment are on the front side. Okay, see here, front side. Okay, yes, see here another example, CH3 LiAlH4. See here we have a two product, that is the OH CH3, both are on the front side, and see here is the OH in the back side. Okay, so see, these are the an example of a stereospecific reaction. Beta chloroperbenzoic acid is a beta perbenzoic acid. B, an example of a stereoselective reaction. If the enantiomers were analyzed, the reaction would also be stereospecific. Okay, ये देखो, तो यहाँ पे एक एग्जांपल दिया गया है, जो एग्जांपल नंबर ए है, तो इसे हम लोग बोलेंगे स्टेरियो स्पेसिफिक. ये क्या है एग्जांपल नंबर ए, दैट इज द स्टेरियो स्पेसिफिक है. ओके, और एग्जांपल नंबर 2 जो दिया गया है, इसे हम लोग करेंगे सॉरी स्टेरियो सिलेक्टिव. ओके, सो वी कॉल देम एज अ स्टेरियो सिलेक्टिव. सी यार, अभी आगे देखते क्या दिया हुआ था. सो illustrates the definitions of this term as originally presented in a stereospecific reaction. One stereoisomer of the reactant give one stereoisomer of the product. ओके, क्या कहा गया है देखो, स्टेरियोस्पेसिफिक रिएक्शन जो होता है तो उसमें क्या हो रहा है देखो, द वन स्टेरियोआइसोमर, एक स्टेरियोआइसोमर रहेगा ऑफ द रिएक्टेंट गिव द वन स्टेरियोआइसोमर, वो क्या करेगा, एक स्टेरियोआइसोमर देगा प्रोडक्ट का. While a different stereoisomer of the reactant give a different stereoisomer of the product. क्या कहा गया देखो, while a different stereoisomer of the reactant give a different stereoisomer of product. Hence, to determine whether a reaction is a stereospecific, one has to examine the product ratio from the different stereoisomer of the reactant. An example would be a epoxidation of a 2-butane by M-chloroperbenzoic acid. Yes, the trans olefin give the trans epoxide and the cis olefin give the cis epoxide. Okay, तो इसे हमने देखा है. Okay, yes, see here SN2 reaction are also stereospecific. SN2 जो reaction रहते हैं वो भी क्या रहते हैं, stereospecific रहते हैं. Is the inversion of a stereochemistry on the stereogenic center is a consistently observed. So that enantiomers of the reaction must give the different enantiomers of the product. क्या कहा गया है देखो, so that the enantiomers of the reactants must give the different enantiomers of the product, must give the different enantiomer of the product. Okay, so see here. Okay, for a few other examples, see the table number 3.11a. A reaction need not be perfectly stereospecific if an 80-20 ratio mixture of a stereoisomer is produces. Okay, यस, दैट मीन्स देखो 80:20 इसका क्या होना चाहिए रेशियो. यस, वी वुड कॉल द रिएक्शन इज 80% स्टेरियोस्पेसिफिक. वेदर अ रिएक्शन इज और इज नॉट स्टेरियोस्पेसिफिक हैज अ सिग्निफिकेंस मैकेनिस्टिक implication, and we will look at the stereochemical analysis of this sort in the future chapter. Okay, in essence, when a reaction is stereospecific, a common intermediate cannot be involved in the mechanism of the reaction of the two stereoisomeric reactants. Okay, देखो क्या कहा गया है यहाँ पे, in essence when a reaction is a stereospecific, जब reaction stereospecific रहने वाली है, a common intermediate cannot be involved in the mechanism. क्या है, तो common intermediate involve नहीं होगा mechanism में. Yes, mechanism of the reaction of the two stereoisomeric reactants. Yes, a stereoselective reaction is one in which a single reactant can give two or more stereoisomeric products. Okay, क्या कहा गया देखो, a stereoselective reaction is one in which a single reactant can give two or more stereoisomeric products, and one or more of these products is preferred over the other. Okay, even if the preference is a very small, now we only need to examine one stereoisomer of the reactant to make this determination for the reaction. In fact, the reactant may not even exist in a stereoisomer, yet the reaction can be a stereoselective. Okay, तो क्या कहा गया देखो, stereoisomer रहेगा तो क्या रहेगा, stereoselective रहेगा. Okay, so see another example in a table number 3.1b. See here, the example are given. See, these are the substitution reaction. Okay, these are the carbon addition reaction, and these are the elimination reaction. Okay, see here, three types of reaction are given here. That is the substitution reaction, carbon addition reaction, and the elimination reaction. So see here, simple we can say that a reaction is also stereoselective when two stereoisomer of the starting material give the same ratio of a stereoisomeric product. Okay, क्या कहा गया है देखो, if the reaction is also stereoselective when two stereoisomer of the starting material give the same ratio of stereoisomeric product. Okay, stereoisomeric product के same ratio यदि वो दे रहे तो इसे हम लोग क्या बोल सकते हैं, stereoselective, as long as the ratio is not 50:50. Yes, this just means that the reaction is not stereospecific. Okay, इसका मतलब क्या हो रहा है, जो reaction दिया हुआ वो stereospecific नहीं है. For example, this may occur if the mechanics of the reaction for the two stereoisomeric reactants proceeds through a common intermediate, and that intermediate give a two stereoisomeric product with one in the excess. However, there are also reactions where the different stereoisomeric reactants give the same ratio of a stereoisomeric product, even when the common intermediate is not formed. That is a 1C. Okay, so here stereospecific reaction, stereoselective reaction, and the stereoselective but not stereospecific reaction. Okay, so these are the three examples given here. Okay, A, B, and C. Okay, see here, the ratios are given here. See here, in a B type we have a ratio 90:10. Yes, in a C type we have the ratio 60:20:20, 60:20:20. Okay, see, all stereospecific reaction are the stereoselective, but the converse is not true. Another example of a stereoselective reaction is the reduction of R3-chloro-2-butanol. क्या दिया गया है देखो, another example of a stereoselective reaction is the reduction of a 3R3-chloro-2-butanol. Okay, in this case two products are a distereomers. Okay, तो इसमें क्या होने वाला है, दो जो प्रोडक्ट रहने वाले वो क्या रहने वाले, डाइस्टेरियोमर्स रहने वाले, एंड द रिएक्शन इज रेफर टू एज द डाइस्टेरियोसिलेक्टिव. ओके, और रिएक्शन तो क्या कहेंगे हम लोग, डाइस्टेरियोसिलेक्टिव कहेंगे. दिस रिएक्शन इज ऑल्सो स्टेरियोस्पेसिफिक. ये जो रिएक्शन रहेगी वो भी क्या रहेगी अपनी, स्टेरियोस्पेसिफिक रहेगी. इन दैट 3-chloro-2-butanol will give a different ratio to produce with the same reducing agent if the two products are the enantiomers, as in the form of the reduction of the 2-butanol. The reaction is a enantioselective if one enantiomer is formed preferentially. Okay, तो इसे क्या कहेंगे हम लोग, enantiomer कहेंगे. So see here, C2 axis of homotopic faces, minor plane only, plane of the carbonyl enantiotopic faces, no symmetry, asymmetric distereotopic faces. See here, equivalent product homomeric. ये तो रिएक्शन यहाँ पे दिया हुआ है, reaction with a bottom face, reaction with a bottom face, reaction with the top face, reaction with the top face. Okay, same way reaction with the top face and the reaction with the bottom face. Okay, so here we get equivalent product, homomeric कहेंगे इसे, enantiomeric product. Okay, so here is the enantiomeric product and here is the distereomeric products. Okay, sorry. So these are the stereochemical consequences of reacting three different types of carbonyl with a hydride reducing agent. Okay, unfortunately here, unfortunately an alternative usage of this term exists. Okay, तो क्या यूजेस है देखो इसके. Often in the organic synthesis literature, stereospecific is taken as, okay, so see here, taken to mean 100% of stereoselective. This is necessarily Burgu restriction because it depends on the tools used to measure the product ratios. A reaction that appears stereospecific by a relatively crude measure such as optical activity may turn into a stereoselective. क्या रहेगा, stereoselective में वो turn हो जाएगा. Yes, reaction when the chiral HPLC reveals 99.1% product ratio. ओके, इसका रेशियो क्या रहेगा, दैट इज द 99.1% प्रोडक्ट रेशियो रहेगा. क्या रहेगा, 99.1% प्रोडक्ट रेशियो रहेगा. ओके, So it is a ratio of 99.1%. Yes, also the mechanistic implementation of the stereospecificity are lost in these alternative uses. However, it seems likely that both uses will exist side by side for the same time. Okay, and the student need to be aware of the distinction. Okay, then here terminology aside, the reaction of a chemical sample composed of only a chiral molecule such as a 2-butanol cannot give rise to the product with any chiral bias, that is any enantiomeric excess. Without the invention of an external chiral influence, this observation has a significant implication for discussion of a such topic as the origin of a chirality in a natural system. A term similar to stereoselective is a रेडियो सिलेक्टिविटी. ओके, तो रेडियो सिलेक्टिविटी भी एक टर्म है यहाँ पे दिया हुआ. ओके, तो क्या है समझ लेंगे उसके. रेडियो का मतलब क्या होता है. रेडियो इन द कॉन्फ्लिक्ट इज डिफाइंड एज द साइट इन अ मॉलिक्यूल वेयर अ रिएक्शन कैन ऑक्यूर. ओके, तो क्या है एक साइड है मॉलिक्यूल का जहाँ पे क्या हो रही है रिएक्शन हो रही है. एंड द डिफरेंस इन द रिएक्टिविटी ऑफ वेरियस साइट इज कॉल्ड अ रेडियो सिलेक्टिविटी. Okay, and the difference in the reactivity of the various site is called radiochemistry. When more than one site react, a radioselective reaction is a one where an excess of one of the possible product developed. A common example is a Markovnikov addition of HCl to a double bond, where the chloride preferentially add to the more substituted carbon. Hence, this is a radioselective reaction. Okay, तो क्या होने वाली हो रेडियो सिलेक्टिव रिएक्शन होने वाले. हेयर द 2 कार्बन ऑफ द अल्किन आर कंसिडर टू बी अ 2 regions. Okay, or site in the molecule that can react. Once again, there are varying degrees of radioselectivity ranging from 100 degree completely selective or 0 degree that is a completely unselective. Okay, so these are the about the stereo selectivity and stereospecificity, even also radio selectivity or radio chemistry. Okay, so here some solve examples are given. So see here, what is the action of MCPBA to the trans-butene? Okay, so see here MCPBA, that is a metachloroperbenzoic acid. Okay, so see here the reaction are given. We actually here the trans are given. So we know that one is a attack from the front side. Okay, if we see the solid wedge, that means like that. Okay, that means the front side attachment. Okay, if the attachment is like that, then it is a front side attachment. Okay, and if we see like that, then it's the backside attachment. Backside attachment. Okay, so we call them as a backside attachment. क्या कहेंगे इसे backside attachment कहेंगे. Okay, so see here trans-butene metachloroperbenzoic acid give trans epoxide. क्या देंगे इसको trans epoxide देंगे. Okay, what is the action of metachloroperbenzoic acid on the cis but butene? Yes, so here action on cis. Here cis are given, so that is the same side, and here we get the both attachment from the front side. Okay, front side में रहने वाला है. दोनों attachment क्या है front side में रहने वाला है. Okay. See here another question, short answer question. Define stereochemistry. क्या है stereochemistry? Stereochemistry is the study of the static dynamic aspect of the 3-dimensional shape of the molecule. Okay, write the reaction between 2-methylpropane and the HCl. See here 2-methylpropanes are given HCl, so we get the product, 2 product, that is the major product and the minor product. Okay, yes, so see the significance of chirality and the stereo आइसोमरिक डिस्क्रिमिनेशन. ओके, तो ये जो पार्ट है हम लोग अभी अगले वाले लेक्चर में देखेंगे. तो अभी यहाँ पे हम लोग रुकने वाले.